Hi everyone. Today we'll talk about absolute and local extrema of functions. In the first exercise, we must find the absolute maximum and minimum values of the following two functions on the interval from -3 to 3. If you would like to try this exercise on your own first, stop the video now. You can download these notes using the link in the video description. The absolute maximum of a function is the largest value the function takes. To find it, look at the graph of the function and find the point on the graph of the function that is the highest. I believe in the first example, the point at x equal to 3 is the highest. The value of the function at x equal to 3 is 3. The y-coordinate of that point is 3, which means that the absolute maximum of this function is 3. The absolute minimum is the lowest value the function takes. It occurs at x equal to -3 in this case. The value of the function at x equal to -3 is -2. The absolute minimum of this function is -2. In the second example, the absolute maximum occurs at x equal to 1, and it equals 2. The absolute minimum occurs at x equal to -3, and it equals -3. More formally, the absolute maximum of a function is a value that is the largest out of all possible values of the function. And the absolute minimum is the smallest value out of all the possible values of the function. We sometimes call the absolute maximum the global maximum. And we sometimes call the absolute minimum the global minimum. Collectively, the global maximum and minimum are called global extrema or absolute extrema of the function. If I gave you these two graphs and I asked you to find absolute maxima and absolute minima, I do not think you would have trouble with that. In the first example, the absolute maximum happens at -3, absolute minimum occurs at 3. In the second example, absolute maximum occurs at -3, absolute minimum occurs at -1. And you could determine what those maxima and minima are. However, there is something special about few other places on the graphs of these functions. For example, if you take a look at the first graph, focus on x equal to -1. The point on the graph of the function corresponding to x equal to -1 is not the absolute minimum, because there are points on the graph that are lower. However, if I look only at points near -1, if I only look at this interval, meaning I only look at a small piece of the function, that point will be the lowest on that small piece. We could say that locally, in the neighborhood of -1, the value of the function at -1 is the smallest. We call that value a local minimum. It's not globally the smallest value, but locally it is the smallest value, which means that there is a local minimum which equals -1 and occurs at -1. Similarly, at x equal to 1, something special happens. If I only look at a tiny interval around 1, I only look at the inputs close to 1, then the value at 1 will be the largest. We call that value a local maximum. In this function, at x equal to 1, we have a global, or rather a local maximum of 1. I should point out that the value of the function, let's say at -2 or at -2.5, is neither a local max or local min. Because no matter what small interval I choose around that point, and I look at the piece of the graph there, the points on the left side will be always bigger, and the points on the right side will be always smaller. Which means at x equal to -2.5, I do not get a local max or a local min, because no matter how small interval I draw here, this will not be the highest nor the lowest point on that interval. In example number 2, I also have a few local maximums and local minimums. At x equal to -1, I have a local minimum. I can draw a tiny interval around -1, and on that interval, this is the lowest point. So at x equal to -1, I have a local minimum, and the value of that local minimum is -1. Then, at 1, I have what I call a local maximum. I draw a tiny interval around 1, and I see that if I only look at the values of the function using the domain, the inputs from that small interval, the value of the function at 1 is a local maximum. And I get that the value of 1 is local max. Finally, at 2, something similar happens. If I only look at the piece of the graph, at 2, I have the smallest value locally, and that value is 0. So there is also a local minimum of 0. More formally, if you have a number in the interior of the domain of the function f, then the value of the function is a local maximum if it is the highest or the largest value on some open interval or in some open interval containing c. And it's called a local minimum if it is the smallest value in some open interval containing c. And the first sentence in the table, interior of the domain of the function f, means that it cannot be the endpoint of the domain. So for example, this point cannot be a local maximum, and this point cannot be a local minimum, because these are endpoints of the interval from -3 to 3. Let's see if we understand the difference between absolute and local extrema by completing a problem. If you would like to try this problem on your own first, stop the video now. We must identify all absolute and local extrema of the following function. I will start with absolute maxima and absolute minima. Absolute maximum is the largest value the function takes, and I believe that value is right here. It occurs at 1 and it equals 4. Absolute maximum of this function is 4. Absolute minimum is the lowest value of this function. I believe it occurs at -1 and equals -4. Let's find local maxima now. I believe there are a few of those. There is one at x equal to -3. Note that if I look at the small interval around -3, and I look only at the values of the function in that interval, the value of the function at -3 will be a local max. And it will give me, the value is 2. So there is a local maximum of 2. What about our absolute maximum? Is our absolute maximum also a local maximum? If I take a look at only a piece of the graph, will I also have locally a maximum? And I believe I will. So this global maximum is also a local maximum. 4 is also a local maximum. What about local minima? I believe I have 3 of those. I have 1 here, I have 1 here, and I have 1 here. The first one occurs at -4, the second one at -1, the third one at 3. The values of them are, the first one is -2, the second one is -4, and the last one is also -2. So I have 2 local minima, -2 and -4. And the local minimum of -2 occurs in 2 different places. It occurs here and it occurs here.